And the next problem is we have to find the z transform of x of n is equal to an u of n minus b of p power n u of minus n minus 1. Right? So we know what is the z transform of an u of n. For z transform of an u of n is z by z minus a with mod z is greater than mod a as ROC. Similarly, minus bn u of minus n minus 1 as the transform of z by z minus b, because minus an u of minus n minus 1 is z by z minus a, so it is z by z minus b. So mod z must be less than mod b. So for together, what is the z transform? We have to add 1 and 2. So x of n is equal to 1 plus 2. Right, x of z is equal to z transform of x of n, that is 1 plus 2, right? So what is the answer? Z by z minus a plus z by z minus b. Sorry, z by z minus b. So mod z, ROC is mod z must be greater than a. So mod z must be greater than a and mod z must be less than b. So this is the collective ROC. Fine. Okay, how to draw this? It is a two circle, right? So we have two functions, so we need two circles. I draw properly. Fine. So here you see circle 1, 2, right? So x-axis real part of z, y-axis imaginary part of z, right? So let us assume this is z a, this is z is equal to b. So what it is telling, z should lie between a and b. So this is z is equal to a circle, this is z is equal to b circle. So mod z should lie between a and b. This is a, this is b. So a and b means in between a and b means this ring. So this is the area. Fine. So this is the ROC. This shaded region is ROC of double side sequence. Here you see, we know it is a right side sequence. This is left hand side sequence. So for double side sequence, ROC lies between the ring. Okay. So this is one more important problem. And next problem is x of n is equal to, what is that? A power mod n in where mod a is less than 1. Fine. So for this we have to find z transform. How can we find? We know x of z is equal to summation n goes to minus infinity to plus infinity x of n z power minus n. So that I make it as my summation n goes to minus infinity plus infinity a, right? So this is minus a power n z power minus n. Yeah, right. So this n will take both positive, this n will take both positive and negative, right? If n is negative, what will happen? When n is negative, that is minus infinity to minus 1, this will be a power minus n z power minus n negative. Here you see n negative, n is up to negative number. N take positive also, so n goes to 0 to infinity a power n z power minus n. N, you see n negative, n positive. Okay. So summation, I can write, I have equation for only positive, right? Already we have seen this. So I convert every negative now n into positive n by multiplying with the minus 1. So it will become n is equal to 1 to infinity. Summation infinity to 1 or 1 to infinity same, right? So I multiply by minus 1, so it will become 1 to infinity. N becomes positive. I multiply by every n by 1, so a power plus n, z power plus n. So a is z power plus n. Then summation n goes to 0 to infinity a z power minus 1 whole power n, right? So this one we have seen already how to write it. So it is 1 by 1 minus 1 by az. This is what summation n goes to infinity. If you have any doubt, please refer the class an u of minus n minus 1, right? So this one we know n goes to 0 to infinity is 1 by 1 minus a z inverse. Clear? So if you simplify what you have, this will bring this side 1 minus a z, this one will be cancelled. So what will happen? Minus a z divided by 1 minus a z, right, plus 1 by 1 minus a z power minus 1. Fine? Okay. So next what we have to do, we have to simplify this, right? Okay, then what will happen? This will be okay. This is minus a z divided by 1 minus a z plus 1 by, this is a by z, so z by z minus a into z. Fine. So this will be like this. Okay, here what I do, here I take a outside, a outside means this will become a z divided by a I take outside, minus will be here, here minus a I take outside, z minus 1. This will be cancelled, z by z minus a. So it will be z by, this is 1 by a, not a I take outside, this is z 1 by a. Z by z minus 1 by a plus z by z minus a. Fine. So this is what z transform of a power a modulus a. Right. So for this we know mod z must be greater than mod a. Clear? Okay. So here you see z is it is left hand side sequence. Right, for left hand side sequence, mod zb must be less than this factor 1 by e. This is right hand side. Right hand side means mod z will be greater, left hand side means mod z will be less. So I told already in problem number 1 and 2. So this is what ROC. Right, so together where will be ROC? So ROC will be, it must be greater than a, less than 1 by a. Z must be greater than a, so greater than a, but mod z must be less than 1 by a. Clear? So here you see this part is talking about left hand side. This one, this part is left hand side area. We know this is left hand side minus. So for left hand side sequence, mod z is must be less than final answer, that is 1 by a. Right? So we get the answer like this. This is what ROC of the given problem. Right? And next problem is, now we see Z transform of sinusoids. The first problem is Z transform of x of n is equal to sine omega naught n u of n. And second problem is Z transform of x of n is equal to cos omega naught n u of n. Right? Okay. So first we take sine omega naught n. So this first problem, right? So x of z is equal to summation n goes to minus infinity to plus infinity x of n z power minus n. So x of n is sine omega naught n, and we know u of n ranges from 0 to infinity. So it doesn't exist for negative n. So I don't need to go for a minus infinity to plus infinity. I go for only 0 to infinity. X of n is sine omega naught n. For positive n, u of n is equal to 1, because u of n is equal to 1 for n greater than or equal to 0. That is n positive. 0 to infinity. 0 when n is less than 0. That is for negative n, u of n is 0. So positive n, u of n is 1. 1 only. So sin x of n is 1. right? So what I do, I can write sine omega naught n as, you see, as per Euler's equation, sine omega naught I can write as e power j omega naught n minus e power minus j omega naught n divided by 2j z power minus n. Fine, so I take 1 by 2j outside, right? So I split this equation into two parts, n goes to 0 to infinity, e power j omega naught n z power minus n minus summation n goes to 0 to infinity, e power minus j omega naught n z power minus n, right? So 1 by 2j, this is what our a, right? So e power j omega naught z is our a, z inverse. So 1 by, I can write as e power j omega naught z inverse n, a n. So 1 by 1 minus e power j omega naught z inverse. Similarly, minus 1 by e power minus j omega naught z inverse. Clear? Okay, this is our a. So a n formula. So simplify it, 1 by 2j, take LCM, so 1 minus e power j omega naught z inverse 1 by 1 minus e power minus j omega naught z inverse. So cross multiply. So 1 minus e power minus j omega naught z inverse minus 1 minus e power j omega naught z inverse. So this one will be cancelled, right? So it will be 1 by 2j, fine. It will, z inverse I take outside, right? So this will be plus e power, okay, fine. So this is plus, minus into minus plus, so this is this one. So if I take z inverse outside, it will be e power j omega naught. This will be minus e power minus j omega naught. 1 will be cancelled. I take z inverse outside. In the denominator, a minus b format. So I simplify it, 1 minus z inverse. I multiply this. I take cross multiplication. E power j omega naught plus e power minus j omega naught plus z power minus 2. It was a simple multiply, cross multiply both the things. So after simplification, what you get is, right, e power j naught minus e power minus j omega naught is nothing but 2j sin omega. Z inverse 2j sin omega naught. Clear? So denominator I take, what I do, so it will be written as 1 minus, right, again it is 2 cos omega naught. So 2 z inverse cos omega naught plus z power minus 2 into z inverse, I wrote here. So what will happen? Here you see, if I take z power minus 2 outside, what will happen? 1 by this 2j will be cancelled. This is z power minus 2 I take outside into z power minus 1 sin omega naught divided by 1 minus, this is z square. So I take z power minus 2 outside, so it will be z square minus 2z cos omega naught plus 1. Fine, so I take z power minus 2 from this, so it will be z square minus 2z cos omega naught plus 1. This is 1 by z inverse. 1 by z inverse is nothing but z. So z into sin omega naught divided by z square minus 2z cos omega naught plus 1. This is what x of z. With ROC, mod z must be greater than 1. Right? Why mod z must be greater than 1? We see. Right? We know e power j omega naught z inverse must be less than 1. It is a right hand side sequence only, right? So you see the problem is, okay, this is right hand side sequence. For right hand side, mod z must be less than a, so this factor must be less than 1, right? So 1 by e power j omega naught z inverse must be less than 1. So this indicates mod z. This z will come here greater than e power j omega naught, right? Or mod e power j. This implies mod z must be greater than 1 because mod e power j omega naught is equal to 1, right? So this is one thing, and another thing is you see e power minus j omega naught z is for second part must be less than 1. So take modulus on both sides. So what will happen? This is 1, z power minus 1, that is 1 by z. Mod e power j omega naught is 1, z power minus 1 by z, it is less than 1. This implies mod z must be greater than 1. So ROC is mod z must be greater than 1. Right? Similarly, for cos omega naught second problem, x of n is equal to cos omega naught n u of n. This is also right hand side. U of n is right hand side sequence which exists for n greater than 0. So this is a question. So we understood it is right hand side sequence. Okay, follow the same procedure. X of z is equal to summation n goes to 0 to infinity because u of n is right hand, so I go for 0 to infinity. X of n is cos omega naught n. For n greater than 0, u of n is 1 into z power minus n. Simplify as usual, use Euler's formula. So what I do? Summation n goes to 0 to infinity. Cos omega naught I write as e power j omega naught n plus e power minus j omega naught n divided by 2 z power minus n. Fine. So I take 1 by 2 outside. Split the equation, n goes to 0 to infinity, e power j omega naught n z power minus n plus summation n goes to 0 to infinity, e power minus j omega naught n z power minus n. So as usual, an formula, right? So 1 by 2, fine. So 1 by 1 minus e power j omega naught z inverse plus 1 by 1 minus e power j omega naught z inverse. Right? Follow the same procedure that we did for sin omega naught n. What we get is, here we get 1 minus z inverse e power j omega naught plus e power minus j omega naught plus z power minus 2. In the numerator, 2 minus z inverse e power j omega naught plus e power minus j omega naught. Right? Simplify this. We know e power j omega plus e power minus j omega is 2 cos omega naught. So 1 minus 2 you take outside. This is also 2 cos omega naught. Sum e power j omega plus e power minus j omega 2 cos. So 2 I take outside. So 1 minus z inverse cos omega naught. This 2 and the numerator 2 will be cancelled. In denominator 1 minus e power j plus e power minus is 2 cos omega naught. So 2 z inverse cos omega naught plus z power minus 2. Fine. So take z power minus 2 outside. So what will happen? This will become 1 by z power minus 2. 1 minus z inverse cos omega naught divided by z squared minus 2z cos omega naught plus 1, right? So you multiply z power minus 2 z power plus 2 1, z into z power minus 2 z power minus 1, 1 into z power minus 2 z power minus 2. The answer we get. So 1 by z power minus 2 is nothing but z power plus 2. So it will be z power plus 2 multiplied with this. So it will be z squared, bring inside, z power minus plus 2 into z power minus 1, z cos omega naught divided by z squared minus 2z cos omega naught plus 1. So you take outside z minus z cos omega naught divided by Z squared minus 2Z cos omega naught plus 1. This is what the transform of cos omega naught. We have to find ROC similarly. So we know e power j omega naught Z inverse must be less than 1. This implies mod Z must be greater than 1. Right? Why e power j omega naught Z inverse? This is that. It's a right hand side sequence. So e power j omega naught Z inverse must be greater than 1. Here also e power minus j omega naught minus Z inverse must be greater than 1. That also will give mod Z is greater than 1. If you put e power minus j omega naught Z inverse greater less than 1 formula. So this implies mod e power j is 1. Again, Z is greater than 1. So ROC is mod Z is greater than 1. Like we did for sin omega naught. I hope you understand all the problems. If you have any doubt, please ask in comment section. I will clarify. Thank you.